Hi everybody, this is Professor Mankowski, and in this video we're going to go ahead and we're going to take a look at question 1 on our practice sheet here. So I'm going to go ahead and I'm going to bring up a whiteboard screen. And to get ready for problem solving strategy, first thing that I've done on the screen is I've gone ahead up to the top and I've written down all my key formulas for the chapter with a few notes about when to use which one, and that's going to help me with my strategy. And the very first thing that I'm going to do is I'm just going to read through the question. I'm going to just write down all the numbers that they gave me. And it says, from extensive experience in industry, a certain jet ski dealer knows that when traded in, a Sea-Doo has had an average of 208 hours of engine time with a standard deviation of 21 and a half hours. Would you be surprised if the dealership told you she had a used jet ski with less than 100 hours on it? Sea-Doo engine hour time fits a normal distribution, and your answer should include a probability computation. So first thing I'm thinking of is I want to get labels on these numbers. And if I go back to the 208, they said that a Sea-Doo has had an average of 208 hours. So that's telling me the 208 must be my population average mu. Now, how did I know that that was not an X bar, a sample average? That's because they did not say anything about a sample size in the question, so I know that 208 can't belong to anything that would be connected with a sample. Now, 221.5 is mentioned as a standard deviation, so that tells me 21.5 is equal to my population standard deviation, which would be sigma. And they mentioned that the dealership told you a used jet ski had less than 100 hours on it. So because they're mentioning this in the context of a jet ski, it means one single jet ski. That must be telling me that my 100 is going to go with my X. And that's going to be really helpful for when I figure out what formula to use. And what they're trying to get me to figure out is what's the chance that any given jet ski will have less than 100 hours on it. Okay, so how do I figure out where to go with the formulas? If I look at the formula in top right here, this one says, sorry, not top right, the center. Only use this, the notes say if they gave me an area or they gave me a probability first, and they did not do that. So it looks like this formula is out. If I look at the one on the right here, this is for the central limit theorem. It's for using sample averages. But again, they didn't mention anything about a sample. Definitely not a sample average. So that lets me know that that formula is out. And the last one here is applicable because, well, not only it's the only one left, but they're telling me it works for an individual data value, and inside the question, they use that keyword A. So individual data value is exactly what they're looking for. Now, can I just run off and use this one right away? Almost. What I have to check is that my data is normally distributed first. And inside the question, they did tell me I'm normally distributed. So I'm going to go ahead. I'm going to start to sketch a normal distribution curve, just like this. Center of the curve, I'm going to put in the average of the distribution, which is 208 hours. My X value is going to go in next, which is 100. And what I have to do is I have to figure out how much area in the curve is less than 100 hours. So to gear up, what I'm going to do is I'm going to start to run my Z formula. I'm going to take Z equals X minus mu. X is 100. My mu is 208. And my sigma is 21.5. When I calculate that out in the machine, I get minus 5.02, rounding to the hundredths digit. Okay, so now what I do is in my Z table, I know that any number that's less than minus 3.49 is going to be equal to 0.0001 area. And obviously negative 5.02 is more negative than minus 3.49. So that's letting me know that my final answer is going to be 0.0001. Now that takes care of part A here. For part C, that should actually read part B, but for part C, they're asking if I would be justified in telling the dealer, telling the dealer you should check to see if the original owner rolled back the odometer. And I would say probably yes, because The probability of finding a jet ski with such low usage is almost minuscule. So it is possible that that person might have lied about their engine hour time, maybe to get a better buyback, rather a better value when they went to sell that vehicle back to the dealership. I hope this was helpful, and I'll see you on the next video.